Hello friends, welcome back. Today we'll be learning operation on real number. Till now we have seen what is real number, now we will see operation on real number. When we see operation, the meaning of operation is the method by which action are done. On real number, how we do some action? We do some action by addition, subtraction, division and multiplication. So in the previous class we have seen that rational number satisfy three property, that is commutative, number 1, number 2 associative, and number 3 distributive law. Distributive law over multiplication. For addition and multiplication, what is commutative? That is for, I'll make a box here. This is review for you all. Under addition, under multiplication, commutative means take any two rational number and add them. A plus b is exactly equals to b plus a. Please don't be confused with a and b here. A and b is any rational number. Example, it may be 1 by 2, 1 by 4, etc. And in case of multiplication, a multiplied by b is same as b multiplied by a. And associative means here we take three rational number, a plus b we will add first and then we will add c. Is exactly same as a plus first add b plus c and then a will give same. In case of multiplication, a multiply b first, then c is same as a multiply first multiply b and c then with a. And distributive law means over multiplication, a into b plus c is same as, this is addition, a into b plus a into c. Further, we have also seen one more property, that is closure. Yeah, closure. Closure. What is that? If we add or multiply or we divide except 0, we get a rational number. Closure means take any two rational number, a and b, add them, again we will get rational number, p by q type. Take any two rational number, multiply them, again it will be rational number. Take any two rational number, subtract them, again it will be a rational number. This property is known as closure property, or we call this as a rational number is closed under addition, subtraction, multiplication and division. In case of division, we do not want 0 because something divided by 0 is not defined, so it should not be 0. Now we have seen for rational case. Now it turned out that irrational number also satisfy irrational number, a number which cannot be expressed in the form of p by q type. Example, root 2, pi, etc. Now it turns out that it will also satisfy closure, associativity, distributive law for addition and multiplication as well. However, the sum, difference, quotient and product of rational number are not irrational number are not irrational. I'll repeat once again. Whatever property rational number will satisfy up to this, that is commutative, associative, distributive, closure, it will satisfy by irrational number as well. That means when we, in case of a and b, we have considered rational, but if we consider irrational number, it will satisfy same. But now we will see this is one property which irrational number will not satisfy. That is, when we sum at two irrational number, that means it will not satisfy closure property, this fourth one. Example, when we add two irrational numbers, root 2 plus minus root 2, because root 2 is one irrational number, minus root 2 is another irrational number. When we add them, we get a 0. But 0 can be expressed as 0 by 1. Hence, this is not a irrational number. Similarly, when we subtract two irrational number, again this is not irrational, this is rational. And similarly, when we multiply two irrational number, root 5 into root 5 is root 25, root 25 is 5, 5 can be written as 5 by 1, again this is a rational number. Hence, we can conclude that the sum, difference and quotient or product of irrational number are not irrational always, but they are irrational in some cases. Example, root 2 into root 3 equals to root 5, which is irrational. But this is not true for all the cases, but this is true for some cases. Okay, till now we have seen rational number, irrational number and some properties. Now to make more tasty, what we want to do is we want to add them, or we want to mix them, rational and irrational number. So we get some interesting result here. The first result is the sum or difference of rational number and irrational number may or may not be, may be rational or irrational. Okay. When we add or subtract two rational and irrational number, the result is irrational. Sorry, the result is always irrational. Number 2, first we'll see example. Suppose root 2 is an irrational and 2 is a rational. So this is the result is again irrational numbers. And similarly, when we subtract them, result is again irrational. The next is product or quotient of non-zero rational number with an irrational number is irrational. That means when we multiply a rational number with an irrational, 2 into root 2 equals to 2 root 2 is again irrational number. Third case, if we add or subtract or multiply or divide two irrational number, the result may be, both are irrational number, the result may be rational or irrational. Example just we have seen here. Suppose when we add, it may be rational, it may be irrational. Example, root 2 minus root 2 is rational, but root 2 plus root 2 is equals to 2 root 2 is irrational. So it may be rational and it may be irrational as well. Okay, now we will look for the next operation, that is taking square root of real numbers. That means when we take square root of real number, what will happen? Now recall that if a is a natural number, then square root a equals to, suppose, b. Meaning is b square equals to a and b should be greater than 0. This is the what we have learned so far, and the same definition can be we extend for a positive real number as well. That means let a is any real number but it should be greater than 0, then square root of a equals to b means b square equals to a and b should be greater than 0. In section 1.2 we have learned that how to represent root n. That means we have seen root 2, root 3 on a number line. Now in the next section we will learn how to represent root x for any given positive real number x geometrically. Example, suppose x equals to 4.5, then how to represent under root 4.5 in a number line geometrically. Now we will stop here.